Hello. My project proposal is on user item collaborative filtering recommendations for Yelp users. A user item based recommender exploiting the k-nearest neighbor algorithm is what I will implement. It will derive users with similar preferences to predict a user's rating for a restaurant that they have not visited. The aim is to emulate a technical report that I found during my study for creating a recommender. Uh, in the report, the project categorically groups businesses to reduce sparseness and improve predictions, and I will compare my results to the results of this paper. This problem fits neatly with the data analytics track, where we are using the data set with businesses and users and the reviews to predict what a user would rate a restaurant that he has not yet eaten at. It's important to note that this analysis is based on explicit votes, not sentiment analysis, not analysis of the user's search history, and so on. This is an AI problem because to get a prediction for a user, those cases that are similar or close to the user are used to predict the value of the target features of the user. As covered in the empirical analysis paper that I studied, uh, when using collaborative filtering for recommendations, two types of techniques are prevalent, memory-based and model-based. Of these, I picked k-means, k-nearest neighbor, and naive Bayes. Uh, Model-based techniques usually learn some sort of function about the data or use, probabilities, like in the case of naive Bayes. I picked k-nearest neighbors out of these because after my literature study, I found that clustering techniques usually produce less personal recommendations than other methods, and in some cases, the clusters have worse accuracy than the nearest neighbor algorithms. Naive Bayes takes assumptions of data such as conditional independence, while k-nearest neighbor is non-parametric. Which is why I went for it. It does perform badly in case of sparseness, which I intend to counter, just like in the technical report, by, for example, grouping all Mexican restaurants as Mexican, and you know, then running the algorithm. So KNN is a case-based reasoning approach. We find the k nearest or most similar objects to a particular object on the basis of some similarity criteria or distance metrics such as Pearson's correlation or cosine distance. Then the output is a rating prediction for a business between 1 to 5 based on k nearest users. Uh, the language I'm using is Python as it is easy, intuitive. Also, one of the best languages for data science and data analytics out there. It has pandas for data pre-processing, wrangling, and everything. And for machine learning, it has the scikit-learn package along with surprise.ai, which has functions for different supervised and unsupervised learning algos. I found code for implementing k-nearest neighbor on the famous movie lens dataset. I will try to use that and use those steps too on my Yelp dataset, which essentially has again users, items, and ratings. I try to use the same dataset as the one mentioned in the technical report for the sake of comparison. Also, it has been found that algorithms designed specifically, collaborative algorithms are designed for data sets where there are many more users than items, such as in this case, where the Yelp data set contains 40,000 users plus and about 10,000 businesses. So it makes sense. Then the evaluation criteria is the root mean squared error, which is covered in our AI book in the syllabus. We For each ratings prediction pair, we will find the root of the square of the distance between them and compare to the paper's results as mentioned in the slide. Also, the technical report uses the k-fold cross-validation concept, which is also mentioned in our book. The idea is to use to get lower bias during evaluation by dividing the data into folds or chunks, such as 10 folds, and then the first fold is tested, the rest used for training, then the second, and so on. From my reading, I found that most machine learning implementations use K as 10 for low bias, which must be the reason why this paper used it. It wasn't justified. And yes, that. Thank you.